Waves. Subtopics: formation of pulses and waves, transverse and longitudinal waves, definition of terms, wave equation. Introduction. Our physical environment experiences a lot of phenomena arising from wave energy. Examples include earth tremors, motor explosions, radio and television, and satellite communications and ocean waves, among others. In this topic, we are going to learn about the general properties of waves. Formation of pulses and waves. Pulse. What comes to your mind when you hear the term pulse? Play the animation and observe the action of a pumping heart and a tuned loudspeaker. Observations. The heart is observed to beat regularly or rhythmically. The tuned loudspeaker cone surges back and forth at regular intervals. Each of these movements is called a pulse. A pulse is a burst of wave energy caused by a disturbance on a medium. Pulses can also be produced by disturbances in a rope, slinky spring, and other vibrating objects. Wave. Play the video clip which involves disturbances in a slinky spring and make observations. Longitudinal and transverse waves. In the video clip below, observe the effect of disturbing a slinky spring along its axis in and out. Wait to view the second portion of the clip in which the disturbances are perpendicular to the spring. What is the main difference between the two waves produced? Longitudinal waves. This is whereby the wave vibrations are in the same direction as the direction of travel of the wave. Examples of such waves include waves traveling along the axis of a slinky spring and sound waves. To demonstrate longitudinal waves, drag and drop the hooked mass on the hook of the helical spring and note what happens. Longitudinal waves, transverse waves. This is a wave in which the wave vibrations are at right angle to the direction of travel of the wave. Examples of such waves include water waves, light waves, and radio waves. Definition of terms. The following are the terminologies used in description of waves: amplitude, wavelength, frequency, and periodic time. These terms are explained with the aid of animations presented in the next section. Amplitude A, frequency F, period T. Click on the button to observe the movement of a loaded spring. Note in particular the limits within which the hanging load moves and how fast it does so. How many complete rounds of to and from motion does it make in 1 second? Observations. The object moves between its rest position O and the maximum displacements P and Q. It completes 2 oscillations or cycles in 1 second. The maximum displacement OP or OQ is called amplitude. Amplitude is the maximum displacement in a wave. Since 2 oscillations are made in 1 second, frequency of the wave is said to be 2. Frequency is the number of complete cycles made in 1 second. Another important quantity is the periodic time or period. 1 period is the time taken to complete 1 cycle. Determine the periodic time of the wave motion just demonstrated. Introduction. Our physical environment experiences a lot of phenomena arising from wave energy. Examples include earth tremors, motor explosions, radio and television, and satellite communications and ocean waves, among others. In this topic, we are going to learn about the general properties of waves. Formation of pulses and waves. Pulse. What comes to your mind when you hear the term pulse? Play the animation and observe the action of a pumping heart and a tuned loudspeaker.
Conclusion. A pulse is a single disturbance formed by a vibrating medium. A wave is formed by a combination of pulses. There are two types of waves, namely longitudinal and transverse waves. A longitudinal wave is formed when the wave particles move parallel to the direction of the wave and consists of rarefactions, that is, low pressure regions, and compressions, that is, high pressure regions. A transverse wave is formed when the wave particles move perpendicular to the direction of travel. It consists of crests and troughs. For any traveling wave, the relationship between velocity, wavelength, and frequency is given by velocity is equal to frequency times wavelength.